This lesson is about scale diagrams. Scale diagrams are important because they help us represent much larger objects that are available in the real life in much smaller terms on pieces of paper. For example, you cannot draw a very big house in its actual length on a piece of paper. You need a very large piece of paper for that. And so you need to use the drawn length that is much smaller and it helps you represent the actual length. So in this case, we can say that the drawn length is always small and it is represented in small units such as millimeters or even centimeters, whereas the actual length, the length of a large object, is usually big and it's represented in units of meters and maybe even kilometers for very big objects. Another example is that, for example, you might be 1.6 meters tall. However, you would need 1.6 meters at least of paper to draw yourself on a piece of paper. However, you can draw yourself using the drawn length and scale yourself down and draw a 16 centimeter representation of your own self. So here we can establish a relationship between the drawn length and the actual length. We can calculate the actual length by multiplying the drawn length by the scale factor. And we can also calculate the drawn length by using the actual length and dividing it by the scale factor. We can start here with a few examples and we will use the relationship that we have established here for the next examples. In this example, it says here, on a scale diagram, the scale 1 represents 20. So we can see already here that we've got 20 as our scale factor. Find the actual length if the drawn length is 3.4 centimeters. So we have a small value here and we are trying to calculate the actual length that is much larger. And if we go up here, we've got the relationship that we have already established, which is actual length, which is the thing that we don't know, the thing that we are trying to calculate, equals drawn length multiplied by the scale factor. And we have all of the information we need to solve this question. We've got the scale factor, which is 20, and the drawn length, which is 3.4 centimeters. So we write here 3.4 centimeters multiplied by 20. And if we do the multiplication, we will find the following. 0 multiplied by 4 is 0, 0 by 3 is 0. We add another 0 for the next digit. 2 by 4 is 8. 2 by 3 is 6. We add that all up and we get 680, but we've got a decimal point here, a single decimal point. So we put the decimal point in the correct place with a single decimal place here. So the answer would be 68.0 centimeters, because this is the unit that we started with. So we can already see that the drawn length is 3.4 centimeters, it's small, and the actual length is 68 centimeters, and that's large. Now, if we want to do the opposite of it, the drawn length, find the drawn length if the actual length is 2.4 meters. We can see that the actual length already has even larger units than the drawn length. We go back up to our rule and we're trying to calculate the drawn length. And that would be drawn length equals actual length divided by the scale factor. So write that down. Drawn length equals the actual length divided by our scale factor. Again, we have all of the information we need. The actual length is 2.4 meters. And we divide it by the scale factor, which is right here, and that is 20. So if we want to do 2.4 divided by 20, we will get 2.4, we'll regard it as 24, divided by 2, that will be 12 over here. So we'll put 12 with a single decimal point here. Again, we're dividing by 10, and that will be 12 meters. Centimeters, sorry, confused myself. Now the next question. The scale on a diagram is 1 represents 500. Find the actual length if the drawn length is 6 centimeters. So we have our scale factor here. I'll write that down. And we have the drawn length here. And they are asking for the actual length. I'll put a question mark. What is the equation that we used? Let's go upstairs. Actual length equals drawn length times the scale factor. Write that down again. Actual length equals the drawn length times the scale factor. And what is the drawn length? It is 6 centimeters. And what is the scale factor right here? It is 500. So 6 times 500, we have 2 zeros. We put them down. That is easy. So you ignore the 2 zeros now. 5 times 6, this is 30 centimeters. 3,000 centimeters we've got over here. If we want to convert it to meters, in order to convert centimeter to meter, we divide by 100, sorry. And if we're converting meter to centimeter, we multiply by 100. So 3,000 centimeter divided by 100, cancel the 0. 1 0 goes with 1 0, next 0 goes with next 0. We'll get 30 meters. So this is our answer. Both of them are correct. This one is correct and this one is correct. Either way would work. But you can notice here that the actual length is much larger. It's 3,000 centimeters compared to the drawn length, which is only 6 centimeters. And it also can take much larger units than the drawn length. Final example. A scale diagram of a building is drawn using the scale 1 represents 80. So this is our scale factor. If the building is 10 meters high, how big will it appear in the diagram? So this is the same way of asking you what is the drawn length? So they're asking for the drawn length. And they have given us the actual length. They are telling us that the building is 10 meters high. So let's refer to our equations again. And in order to calculate the drawn length, we need the actual length and the scale factor. Sorry. So drawn length, I'll write it down here. Drawn length equals actual length divided by scale factor. And what is the actual length? The actual length is 10 meters and the scale factor is 80, so 10 divided by 80. We've got zeros, so we can cancel the zeros here, and you've got 1 divided by 8. If we do long division for that, we can do long division. What times 8 gives us 1? Nothing. So we put the 0 down, subtract 1, bring a 0 all the way down, right here. What times 8 is almost 10? Got a decimal point here. Say 1 times 8. Multiply 10 minus 8 is 2. Let's put another 0 down. What times 8 is almost 20? 2 times 8 is almost 20 because 2 times 8 is 16. If we subtract that, 20 minus 16 is 4. One more 0 if we put it down. What times 8 is almost 40? 5 times 8 is exactly 40. And this is what ends our long division. So the answer would be 0.125 meters. If we want to convert meters into centimeters, we multiply by 100. So meters to centimeters, we multiply by 100. If we want to convert this to centimeter, we'll do 0.125 meters times 100. And that would be, move the 0 2 times because we've got 2 zeros over here. the answer would be 12.5 centimeters as well. Again, if you put 12.5 centimeters or 0.125 meters, both will be correct. So this concludes our scale diagrams lesson.